Recording and talking.
Okay, so for this problem here, what you want to do is you want to find the point of intersection. So pretty simple. I'm just going to work it out, and I'm going to try to maybe save my work as a PDF just so it's a screenshot. But I would just set them equal to each other, right? That'd be your best bet. So 3x minus 5 equals negative 4x plus 9. 7x equals 14. Do you guys get 2? Cool. And if you plug it back in either equation, you should get 1, I think. Cool, good. You can graph them as well. If you graph them, they should intersect at 2, 1. So hope that's pretty straightforward. For 47, what I would do is I would plug 1/2 into plug in each number into the equation 1 over x. Now, remember, if you have 1 over a fraction, what do you do to the fraction on the bottom? You flip it, so it becomes 2. Or multiply by reciprocal, same thing, right? How about the next one? That would be just 10, right? Now, 0.01, can you guys convert that to a fraction?
Yeah.
What is that as a fraction? And if you flip it, what do you get? Perfect. And then lastly, what's that as a fraction? Yeah, exactly. So you got to flip it. And yeah, leave it like that. That's not reducible. So, okay, let me save that as a PDF. Okay. And, prior I was like doing screenshots from the CPM textbook. I think this is a little better because you actually can see the full solutions, and I'm recording it too. So you'll have the recording to access if you're ever reviewing your homework and you're stuck. And by the way, how to study for a math test, or specifically for an Algebra 2 test, because this is different than geometry. I'll talk about that on Thursday. But one thing you should do, you should audit your homeworks for sure. Go back and look at your homeworks, make sure your homeworks are accurate. Again, I will put all the answer keys. I still have to do that. That's on my list of things to do. I should look at your notes, audit your notes. If you look at your notes, like, what the heck was that all about? I have no idea. When you're looking at your notes, go back and look at the videos. All the videos are there. Alexandra?
Mark off points if we just did 1 over 0.01.
I didn't specify how to express the answer. So you're not, no. I mean, if I did say simplify or give as an integer, then yeah. But if I don't specify, you're not wrong. So, all right, let's keep moving. All right, for 48. Okay, this is what I'm talking about. Factoring, guys. We got to talk about factoring. So this is a great opportunity to show you the flow chart. Okay, so I taught, believe it or not, I did teach Algebra 1. I know I teach a lot of the more upper division courses, but I don't teach it anymore now. I don't know why. Just I don't have the patience for Algebra 1. But anyway, factoring flow chart. So this is a nice flow chart because what's happening here is that you're starting at the top question, how many terms you have. You have 2 terms, go down to the left. 3 terms, go down the middle. 4 terms, go down to the right. If you have 3 terms, you usually want to look for common factors, pull them out. After you do that, then see if the first and last one is a perfect square. If it is, it's a special kind of factoring called a perfect square trinomial. We'll cross that bridge when we get there. If not, check the lead coefficient as 1. If it's not, then you can just do the diamond. We talked about that in CPM, geometry, or like Algebra 1 in middle school here. We can do that again. Or if it's not 1, they have to do diamond with a box, which we'll talk about in a little bit. I call it grouping, same thing. So in the case that we have here, where is it? Shoots, just lost. There we go. How many terms do I have for part A? 3. So I'm going to go down the middle. Okay. Are there any common factors between these two? Or sorry, among these 3? No. So then I'm going to do, and then is the first and last terms perfect squares? Is 15 a perfect square? No, it's not. So I'm going to do this. Do you guys remember how this works? What do you put up top? You put 15, and what do you put on the bottom? -8, very good. If you put the variable, you can. Some people put like x squared and x. If you want to do that, but I just like having the numbers. That's good enough. Now your task is to find 2 numbers that multiply to 15, add to -8. What 2 numbers do that?
25.
Perfect, good. And then you have the answer. That's it. That's all you do. Well, that's all you do. Then you have to set each factor equal to 0. And why do we do that? Why do we set each factor equal to 0? Exactly. Because anything times 0 is always 0. And what are you multiplying? You're multiplying x minus 5. Bless you. and x minus 3, multiplying two numbers together, one of these two things has to be 0. That was on the quiz, and that's where you guys had some trouble. I'm going to talk about the quiz in just a moment. So either this has to be 0 or this has to be 0. So what does x equal in each case? So what you just did without realizing it, or maybe you don't know the name of it, this is called the zero product property. I'm glad that you guys have your attention. So that's good. So I want you guys to remember zero product property. Think about the words zero product. Product is what mathematical operation? Is that addition, subtraction, multiplication, division? What's product? Multiplication, good. Are we multiplying two things here? And what do you want the product to be? So in order for that to happen, one of these two things has to be 0. That's a zero product property. And if you do that, you get 5 or 3. So either 5 or 3 makes the equation work. Now, what we had on the quiz was this. Remember we had this on the quiz? Now, some of you guys did it correctly. Some of you guys did not. That's okay. You guys are a little rusty. There's only 2 terms, right? So let's look at the flow chart. So I go down to the left. Are there any common factors? You bet. What's common between these two? Pull it out. Many of you guys didn't do that. Actually, I saw some really weird stuff. But it's okay. You guys are just, 3 months since you've done math. After you factor out, you set each one equal to 0. And what do you get? 0 or 5. That's a zero product part. That's what you're supposed to do in the quiz. So I'm glad I did the homework quiz because it opened my eyes that, okay, we got to talk about this. This is a thing, something we have to talk about. Now, part B is a little more challenging. I don't think we're going to have something like this on the tests. I'll double check tomorrow, but we are going to do this eventually. So we do have to be comfortable with this. And you guys did do this in Algebra 1. It's supposed to be reinforced in geometry, but that's okay if you're having a little trouble with this. Do you guys remember how to do something like part B? How would you do this? What's my first step? No, we're going to factor. Oh, does factor not work? Oh, it's not, okay. Actually, that's good. No, but let's try factoring it. Adelaide, what would I put up top? Perfect. What do I put on the bottom? Okay, so actually, Charlotte, you're right. This was not factorable. But how do you know? Let's try all the options. Does that work? No, right? What's the other option? -2 and 6. Close. Or -6 and 2. How about -4 and 3? So have I exhausted all my options? -1, 12, -2, 6, -3, 4. Even if I swap the negatives, I've exhausted all options. So I can't do it. So in this case, it's not factorable. So what would be my next option? Yeah, the plot form. So -5 plus or minus the square root of b squared, which is 25, minus 4ac all over 2a. Nathan, go ahead. I don't think we're going to test the quadrat. I'll let you know. Maybe we'll give it to if we are expecting. I don't think we will for this test, but maybe for a future one. And I think maybe for the first time we do quad form, we probably do, and then we don't after that. After that, we expect to. In the spring, for sure, you need to know it. What's that going to be? 48. That's 73, I think. You get 73? Yeah, over 4, and that's the best you can do. Those are your 2 answers. And that's what makes the equation equal to 0. In fact, these are x-intercepts, right? This is where it crosses the x-axis. They're weird numbers, but, we just go with it.
You don't have to keep going for that, right?
Stop. Yeah.
Oh.
Yeah, just stop. Yeah. Okay, let's keep moving. All right, 49. Plot the points, find the distance between them. When you find the distance between them, you could use a distance formula. I'm not a fan of it because I'm terrible at memorization. In fact, actually, the only science class I've taken over 30 years is biology because I cannot stand memorization. But I love chemistry and physics. So anyway, those are my points, right? So instead, let's actually take a visual approach instead of memorizing. What did I just draw right now? And what are the length of the sides? Perfect. And then how do I find that third side? Perfect. Which you guys know. See, essentially you are doing the distance formula without realizing it, right? And what do you get? 34. So root 34. That's it. Took me less than a minute. Now, the distance formula, if you do want to use it, you can. I won't hold that against you. But it's just a little daunting with all the subscripts and all the variables. I know this because I do this for a living, but You know, you guys have 6 other classes, you have sports, you have lives outside of this. I don't expect you guys to know this. If you want to use it and memorize it, go for it. Personally, I would draw. I'll plot the points and draw. That's what I do. Now the slope. The slope should be pretty simple. Let me get rid of some stuff here. How do I find the slope? Ah, geez. There we go. Yeah, so how far do I rise? So there you go, 3/5. Drawing helps. If you want to use a formula, you could do y2 minus y1 over x2 minus x1. The order in which you subtract doesn't have to be second minus first, it could be first minus second. It's up to you, but make sure it's consistent between x and y. You have 3 minus 0 is 0 minus -5, you still get 3/5. So, okay. So that's 49. Let's look at 50 with the home stretch here. Okay, so Stacy says to Corey, reach into the standard deck of playing cards, pull out a card at random. If it is the Queen of Hearts, I'll pay you $5. Standard deck has 52 cards, each which is unique. So what's the chance that you get a Queen of Hearts? Well, first of all, how many Queen of Hearts are there in a deck? Just one. So it's one out of, there we go, right. So this one's just an old concept. You know, that's all. And what's the probability that you lose or that Stacey keeps her money? Yeah, so it's pretty good odds that she'll probably win, right? Charlotte could. Yeah. I no. We probability I like to call. I don't know why people use this term, the redheaded stepchild of math. And I don't know where that term comes from, redheaded stepchild. It's a weird term, but anyway, it's it's the lemming, the one thing we just don't care about in math because we just got sometimes just throw it to the side. But it's good to know for like SAT, for example, if you're a junior and you got SAT, they could ask that. So I feel like I'm somewhat responsible for making sure you know probability, and it's pretty basic. So, but we don't do it too heavily in this class. Not if you take AP stats or non-AP stats, you would, which is an elective. But this class we don't. We used to 20 years ago, but yeah, just the time's an issue. Okay, what's the error here? I don't know. First, I'm looking at this problem. Yeah, so it seems like it should be negative 5.4x. Yeah, I personally would probably subtract both sides by 9.5. That'd been a better approach. It should have been that. So it should be negative. So yeah, that's all. And I just realized I haven't done screenshots of this stuff. Oh well. That's fine. And then 52. Just move things around. That should be 8.3x and negative 53.8. Am I correct? I'm assuming that. I could be wrong. Yes, no. For 7.3? You are correct. It is 7.3. Thanks. But did you have positive 53.8?
Yeah.
One should be negative, one should be positive. I'll double check your work. I'll just give me a moment. And if you just multiply that out, you should get.
Divide negative 7.3 with positive 53.
Yeah, so it's going to be kind of a weird number. Negative 7.37, we'll say. Yeah. Okay, cool. And then the way I would handle B, I'd convert the 1/5 to maybe 0.2x. And I convert that to a decimal as well, which is going to be 0.52. So you can use a calculator if you need to for that. Somewhere, go ahead.
You can't be like converting slide?
No,
Okay.
not really.
But
No.
unless like says specifically.
Exactly, right. Right. So if you left those fractions, you could have done you could convert 0.7 to 7/10 if you wanted to. But then you have to find the least common denominator to combine it. So it's your call. I just think decimals might be a little easier. And you should get 2.8. That actually came out nice and clean. Cool. All right. So we're good. All right. And so, yeah, I think I'll just make an ANSI key by hand. I've did some screenshots, but at least recorded this. Okay, good. And the extra practice problem. I don't feel like, well, hold on a sec. What if the x-intercepts are this and domain is that? There's more than one function. We'll skip that for now. Let's just move on. All right. So if you guys get your notes out, let's go through the notes. So my plan is not take too long to the notes, hopefully 20-ish minutes. Then you guys can do the homework quiz and you guys can work on homework. Oh, I still need to talk about factoring also. We're going to talk about that, but we did talk about it a little bit using the flowchart. I kind of explained it to you. 100% you will. Yep. Yep.
Is the homework quiz on homework 3 or the one that we just went over?
Homework 3. Oh yeah, I'll tell you right now, the homework quiz is going to be on this stuff. Thank you, Nathan, for bringing that up. It's going to be very similar to number 34, A and B. So I'll give you a graph. It's really just one question. I'll give you a graph. Okay, domain. The homework quiz I'll do at the end of class today. So I'll ask you to give me the domain and give me the range. So if you look at this graph, what's the lowest x value here?
2.
What's the highest x value?
5.
It's hard to tell. It's 4. I know, you guys think back. Don't worry, you'll be able to see it on the quiz. What's the lowest y value? What's the highest?
4.
3. So it goes from -1 to 3. So you would state your domain. You could do it like this in interval notation if you want to start doing that. Or you could do it like this. I'll accept either. And the range you're going to write like this, -1 to 3. Or this. So either's fine. That's what the quiz literally be like. Probably get done like in 15-20 seconds. It'll be fast. Okay, so now let's move on to the lesson for today. Okay, so I'll do this with you guys, just kind of interest of time. And then maybe I'll have you guys do some of these table groups and I'll walk around. And just to give my voice a bit of a break, we'll have some people read. We'll kind of go around. Sophia, do you mind reading the beginning of the page here? Like where it says, what does it mean?
Similar graph and investigate if their functions with the features and form f of x equals 1 over x.
Okay, thank you. And then I'll read the next part. As you work with your team, keep the multiple representation of functions in mind. Multiple representations meaning graphs. Equations. And tables. And then pick a number for with your team for H. I'll pick a number for you guys. We'll say H is 4. We'll do that. H is 4. And we're not going to do this on a large piece of graph paper because I don't have that. But I'm going to kind of walk you guys through this investigation right now. So first, I'll just make an XY table with integer values from 5 less than your value of H to 5 more than your value of H. For example, if you pick H is 7, you begin with 2, and then what you notice about all of your Y values. Okay, so I'll do the table off to the side here. I am going to need more space. Let me do it up here. It's going to be a big table. Now, I chose 4. What's 5 more than 4? What's 5 less than 4? Good. So we're going to start with -1 and then with 9 and do all integers in between. So 0, 1, 2, 3, 4. Oh, goodness. I run out of space here. Kind of. Yikes. Should have been a little more mindful about that. 8, 9. And I'll just kind of do this to kind of keep things easier on the eyes. Sweet. All right. Okay. So again, our equation is this: y equals 1 over x minus 4. So what happens if you plug in -1? What do you get? You get 1 over what? Close. -1 over -5.
Is that the same?
It's the same. Yeah, actually, you know, if you did this, you're right. It's the same thing. You're right. You can see that. What if you plug in 0? What do you get? What's on the bottom? So -1/4. The negative, by the way, can go either top or bottom. They're the same thing, right? Some people like to put the negative off to the side. That works too. Either way, it's totally fine. Shortcut. So what I'm doing is I'm plugging these numbers in into this equation.
Oh.
That's all I'm doing.
So
Yeah,
just
'cause-
for 4.
Yeah, because we chose h is 4, and we're going to graph that equation.
Oh.
So what we're trying to do, we're investigating how this function is going to look. Because right now we don't know unless we go to Desmos, but you guys haven't really done this by hand yet. So what we're doing is we're just exploring by plugging into a table. That's all we're doing. And that's the equation we're going with. Sorry if I glossed over that. No problem. Okay, next up, if I plug 1 in, what's y equal? What if I plug 2 in? 3. Now we get a problem here. It's undefined, right? You can't divide by 0. And then afterwards, what do you think? How do you think the next 5 are going to compare to the previous 5?
Positive.
They'll be positive, exactly. Yes, it'll be 1 half. Geez. A third, a fourth, and a fifth. Okay, so part A is done. Part B, is there any x value that has no y value? Yes. X equals 4. Because you can't divide by 0. Okay. That's why that makes sense. Okay, now we're going to plot the points, but before we do that, any questions before I move forward? So usually when you investigate a function for the first time, the best thing to do is plug in numbers. Because you don't know, right? You've never graphed this kind of function before. You don't know what to expect. You don't understand how it behaves. It's okay. We're going to understand it. It's like the Star Wars, right? Like you don't know anything about Darth Vader. What's Darth Vader's story, right? He was, I don't know, some young kid in Tatooine, and I don't know. I forgot the movies now. No, then he became evil. You know, he fell in love with Princess Leia's mom, and anyway, Queen Amidala. Anyway, let's move on. But you got to investigate, right? We got to figure out, just like that first day I talked about Star Wars, we want to understand the characters, we want to understand these functions, right? Okay, now part C. Plot these points. I'm not going to graph here. I'll just do it off to the side here. So let me do this because I don't have terribly much space. You guys have to squeeze in somewhere. So let's do this. Let's go black. 1. One, 2, 3, 4, 5, 6, 7, 8, 9. And -1. And this can be a little crazy. But if we think about it, it's going to be really, really tiny numbers. Let's go light blue. All right, so 3, -1. 5, 1. I don't know what to do at 4 yet. I'll talk about that in just a bit. Let's see here. 6 half. 7 1/3. 8 1/4. 9 1/5. Does that make sense how I did that? The points are getting closer and closer to the x-axis, right? Very close to the x-axis. Let's do the other side. -1/2. -1/3. -1/4. -1/5. Do those points also get closer to the x-axis? Yeah, they do. So now before I do part D, actually part D is kind of what I want to talk about. Yeah. Add more values to your table, see what's happening as your function gets close to the value of h. choose 8 input very close. Let's hold off on D for a moment. We're definitely gonna do D. We're gonna plug in numbers close to 4. Because our H value is 4. Like I'll plug in like 3.5, 3.6, 3.7, 3.8. Or if we want to be more adventurous, 3.9999999. Or 4.5, 4.4, 4.3, 4.2, 4.1. Or again, want to be adventurous, 4.001. Like get really close to 4. We'll see what happens. We'll do that part D in just a moment. Before I do that, what do you notice when X was getting larger? When X was getting further away from 4, so like 5, 6, 7, 8, 9. What was happening to the Y values? Being smaller. Now let me ask this question. If I were plugging in, say, like 100 for X or 1,000 for X, will these dots off to the right ever touch the X-axis? No, they get awfully close to the X-axis, right? And here's the reason why. You have 1 over a big number. If you replace this X here, let's say like thousands. What happens to the denominator? It's pretty big, 996, right? But what's 1 over 996? That's still a positive number, right? Because is your top still positive? Is your bottom still positive? Yeah, so it's just getting closer to 0. So ultimately, I expect the graph to look like this and just graze the X-axis. It won't cross it, it'll graze it. It's gonna be like that. And likewise over here. It's just going to graze the X-axis. Yeah, totally. Yeah. Because what if I plug in? Well, now we're going backwards, right? So I'm going away from 4 in the other direction. Like 3, 2, 1, 0, -1. Same thing. Now, technically, these are getting bigger. That's kind of weird, I know. But these are actually getting larger. But will these ever get above the X-axis? No. Well, yeah, because if I have 1 over X minus 4. Now, if I plug in numbers here that are more negative, like let's say I plug in -1,000, right? What are you gonna have? You're gonna have this, right? Is the top still positive? But the bottom is negative, right? What happens if you divide positive by a negative? What do you get? No, positive divided by negative. A negative, right? But a small negative number that's really close to 0. So it's never gonna break that X-axis. So the X-axis is kind of like a barrier. It's acting like one. We're noticing this. Okay, that's interesting. Now, I'm gonna get rid of this table because we're done with it. But we're going to make another table, so you might need to find some more space. Hopefully, yeah, you guys got space at the bottom. Okay, I'm not too worried. Okay, you guys are good. All right, so let's do this. Let's make a new table. Part D is instructing us to come up. So we've done A, we've done B, we've done C. It's instructing us to come up with 8 more values. 8 more values that are very close to whatever H is, and suggesting these kind of scenarios. So let's do this. Let's do 3.5, 3.7, 3.9. I'll use their examples. I think it's good. And 3.99. Then we're also going to do 4.5, 4.7, 4.9, and 4.99. Okay, does that make sense? Yeah, Nathan, go ahead. Yeah, go for it. Yeah. Okie dokie. So I'll need to plug this in. So 1 over X minus 4. I don't need a calculator. So let's plug this in. If I plug in 4.5, you should get, and just trust me, you get 2. In this case, you get -2. If I do the next one, 1 divided by 0.7, I get, one sec. Well, I messed up, guys. Shoot. No, okay, no wonder I confused you guys. Hold on, I totally messed up. I meant to do this. My apologies. Yeah, I need to get closer to 4. My apologies. That made no sense what I did. We want to get, so if if you guys are confused, apologies. I meant to put numbers close to 4, not away from 4. That was dumb. So 4.5 is fine, 4.3, 4.1, 4.0. You want to get close to 4 on each side. Because I knew something was off my computer, like, wait one sec, that's something seems a little silly here. So that should be 3.3 repeating. And then this one should be, I think, 10. And then 100. And that will be negative 3.3 repeating. Negative 10. And negative 100. Just trust me, that's what you get if you plug those in. So, yikes, that's crazy, right? So going back to my graph here. Let's erase this junk. Let's erase this. Going back to my graph. Let's say this is a -2, -3, -4, -10, 2, 3, 4, 10. Okay, so what's going to happen is that if I get close and close, like, gosh, it's really hard to do, but it's a 2. So I'm going to do this to help you guys out. We're going to draw a little barrier here. You'll see why we have a barrier in just a moment. I'm going to draw a little barrier like that, which is actually very important. It's actually a big part of what we're doing. But if I plug in 4.5, I get that. Then I get this. Then I get this. It gets really close to that dashed line, right? And just keeps shooting up forever as I get closer and closer to 4. But here's the problem. I know if I plug in 4, I'm gonna have a problem, right? It's going to be undefined. So when you have enough points, be sure that you know the shape of the graph and sketch curve. So that's how the curve looks. It looks like this. It's basically 2 branches where they level off towards the x-axis on the far left, far right. But in the middle, one shoots up forever, one shoots down forever. So let's go to Desmos really quickly to make sense of all this. Y equals 1 over x minus 4. Let me clear. So we see the same thing, right? See how that gets closer to 0 on this side? Close to 0 on this side? But when you get close to 4, as I shoot up, like notice how like y gets really high or y gets really negative, right? So what's happening, when I go back to the graph again, let's undo my erasings. What's happening here, as I investigate this dashed line is called a vertical asymptote. Get used to it. You're going to see this term a lot throughout the year. It's called a vertical asymptote. It's essentially a boundary. It's essentially a boundary you can't cross. So a vertical asymptote is like a boundary. And it's determined by what makes the bottom 0. Whatever makes the bottom 0 is the vertical asymptote. So if you have like x minus 1, then you have an x equals 1. If you have x minus 2, you have an x equals 2. If you have x plus 1, be at -1. X plus 2, be at -2. Also, what's happening is that as we get closer to the vertical asymptote, y goes up towards infinity or down towards -infinity. That's what happens. So let me put some stuff on the bottom to kind of make sure you guys are clear on this. So vertical asymptote occurs when an equation has a denominator, and the denominator equals 0. Also, as x approaches this boundary, y either shoots up towards infinity or down towards negative. Let me space that out a little better for you guys. So it's easier on the eyes. Much better. There we go. So much better. Yeah, so that's what happens. It occurs when an equation has a denominator and the denominator equals 0. So in this case, 4 makes it 0. It's a boundary that we cannot cross. And as x gets closer to this boundary, y will either shoot up, as we saw, or shoot down towards negative infinity. So that's what that does. And also, the equation of this boundary is x equals h when dealing with y equals 1 over x minus h. So when that's the equation we're dealing with, then x equals h is the equation of the boundary. Just so you know. Okay, questions? And that's quite a lot for a Tuesday afternoon after a long weekend. All right, so we're almost done with the notes. Looks like timing's looking pretty good. Now, quickly here, so start by describing the graph. Some graph with special names, key name of the shape, blah, blah, blah. Describing the key points, give domain and range in equality form. Then we talk about asymptotes really quickly, and then we'll stop there. Okay. So this is just stuff you guys have done in the past. We know this already. What shape does h of x give us? What would you say that is? It's a line, totally right. What shape does g of x give us? Yep, you guys know. Perfect, very good. Describe any key points. Well, for h of x, I know my slope is 2. Y-intercept is 3. That's kind of good enough. The domain is all real numbers. It's an inequality form. So I'll do it like this. And the range, same thing. Geez. Okay, that's all good. Yeah, it's just, a line. Not a big deal. No, Jazz, you have to go in a minute, right? We're almost done. And then for parabola, okay. I'll just draw it well, before I draw it for you guys. Actually, yeah, I'll just draw it for you guys. So, not sure if you guys know, but that's a factor like this. This is why I care about factoring a lot, guys, because it helps you with graphing for sure. That does factor like that. What's going to happen is that when you plug in 1, you get 0. If you plug in 2, you get 1. Plug in 0, you get 1. There's something called transformations. You're good. And you can watch a recording. I'll post it. You can do, you already did the quiz. You're good. Yeah. Thank you. Oh, can you hold on one sec? Do this really fast. You got it. You're welcome. Okay. Yeah, so in this case, the domain or the x-intercept is 1. The y-intercept is 1 again. The domain is all real numbers. And the range is from y is bigger than or equal to 1. Sorry, 0. My bad. So that's just more review of old stuff. For parabolas for now, use graphic calculator. By the way, we will, I think we will allow graphic calculators for this test next week. So you could use graphic calculator. Well, eventually you have to do this without a graphic calculator, this parabola. But for now, you can use graphic calculator, that's okay. But you do need to interpret correctly. Do you guys see why the range is greater than or equal to 0? Do you guys see the lowest y value 0, right? And goes up forever. Does that make sense? Okay. Lastly, asymptotes. So I just talked about what this is. It's a boundary for a graph. So mathematically clear and complete definition of asymptote requires some ideas from calculus, which I'm not there yet. You'll be there in 2 years. But some examples of graphs of asymptotes should help you recognize them when they occur. In the following examples, dotted lines are called asymptotes. The equations of the asymptotes are given. So like you see how like we have a vertical dashed line and a horizontal dashed line. Very similar to what we just saw today, right? Today we have y equals 1 over x minus 4. Right? Ah, geez. Hold on. Let's try this again. Remember our graph looked like this, right? So that was x equals 4. And notice we didn't cross the x-axis. That's called a horizontal asymptote. So we also had another boundary, y equals 0. Now, there are times when we can actually cross horizontal boundaries. We're not there to talk about that yet. We'll get there eventually. Sometimes you have something called a slant asymptote. That's a slant. For those who play football, you guys know what slant is, right? Yeah, so I don't need to explain that to you. But actually, any black football players in here? No? Okay. But this is vertical, obviously, and that's horizontal. So asymptotes could be vertical, horizontal, slanted. And I think that's all I needed to say about that today. Okay. So we're all done. So homework is right there. You guys have the homework packet as well. So once you're done with the quiz, you can start the homework. Now, really quick about the factoring. I suggest you do a little bit each day. So like, for example, for this page here, and just 1 through 20, the answers are on the next page. All you're trying to do is find the GCF. So for example, for number 1, what's common between these two? Yeah, 4, and I'm gonna give you the copy of this in just a second. 4 and p cubed. So that'll be 4p plus 1. You do that. Or for like number 8, what's common among all 3 of these? And pull it out. Thank you, Aiden. And remember, if you completely pull a letter out, you have to leave behind a 1 because you have to make sure that you get the end back when you put it back in, when you distribute back in. Okay. I think we're good. All right. So I'll hand this out while you guys are doing the quiz. And again, once you're done, start the new homework, which is homework 5. If you want to do the factoring packet, that's fine too. I am making a factor packet due on Monday of next week. So want to make sure you guys are getting all the factor practice you need. Come by during office hours. I'm available. Tomorrow we have office hours. If we have it, we do. So, and also Thursday and Friday as well. So come by if you need help. All right, so let's go ahead and start the quiz. And I'll pass back the other ones after I record them. I just gotta record them into Schoology. Okay, very simple. Seriously, takes like less than that.